Okay, so this is part 5, and today we are going to discuss about reliability index. Definitely, it's basically fingerprint analysis of Humphrey. So, in case of single print analysis in reliability index, we are going to talk about threshold, Foveal threshold, and reliability parameters. In Foveal threshold, definitely Foveal sensitivity, and reliability. Other indices. One is test duration, false positive and false negative, and fixation loss. That's very important. So it's sometimes like this, isn't it? Foveal threshold 33 decibel, which is approximately better 35, 36 in young patient. Test duration depends upon the which type of program we are using for the threshold determination. Like theta fast will be maximally fast, and standard will be a little bit take time. It will take false negative error, false positive error, fixation loss, or definitely fixation target. It's depend upon the fixation target that fixation loss. What is fixation loss? And fixation monitor gaze, or gaze is definitely we maximum time we use blind spot. So let's move forward. So what is threshold, foveal threshold and foveal equity? If foveal threshold is high, doesn't mean that mean visual acuity is high, isn't it? It's very simple, isn't it? Foveal threshold is high means visual acuity is high. So if there is, if patients has good visual acuity and there is foveal threshold is lesser, then you must understand there is something going on which is not good. So if patient has good visual acuity and significant reduction of foveal threshold at that case, then technician must should be become alert that to check the optical correction uh, is correct or not. So there is high probability that optical correction is not good. At that particular point, you will see that visual acuity is good with glasses and something, and your technician did a wrong test. That's why an optometrist must teach your technician how to do a well job. Okay, it's very important. So fixation loss. What is fixation loss? So it's very important. The monitor by the three methods. Observation by perimetrist. First to observe by no matter what if you are doing or your technician is doing at that particular point, you must observe the manually. So his eye is not wandering around. So perimetrist has video system to project an image to the eye on monitor, and perimetrist has to detect the fixation shift and faulty head position. So it's your manual job. Okay, and another thing is automatic fixation, either signals or the perimetry when fixation is wander or repeated stimulus presentation, it will call automatic fixation. Okay, that's how you look from outside, from camera, and in your monitor you can see that's how. Okay, so another technique is Hazel-Krukov method, and this method is very beautiful method. In this, and upon depend upon this method, there is a fixation loss counting. Okay, in this case, blind spot is localized through not necessarily plotted, but early testing process. What do you mean by early testing process? The early testing process means your central fixation process. In that particular process, blind spot is localized, and the stimuli is then periodically presented in the presumed blind spot area, which is approximately 5% of the stimuli is presented to the blind spot area. And what happens whenever you present the stimuli to blind spot area? Definitely you want to see, isn't it? You cannot see there. The light seen by patient in this area means fixation loss, isn't it? If you throw the light in blind spot, you must not see. If you can see, that's okay, but if you can see, then it's indicated that there is fixation loss. So actually you are throwing light, machine is throwing light to the optic disc, but your optic disc is not there. But what is there? The light sensitive area of the retina. So at that particular point there is a fixation loss, isn't it? So normally fixation loss is 20% is considered unreliable, greater than 20%, and if it is greater than 33%, then machine will show something like XX, isn't it? It's definitely unreliable. So that's the case with the Hazel-Krockow method. Means Hazel-Krockow method means if patient is fixating centrally, the stimulus is presented in the blind spot should not be seen, because in blind spot, if you project this yellow light, then patient should not see it. If patient drift the eye from the fixation point, then blind spot is also drift, and then machine project at previous area, and that this area patient can see because this area is light sensitive area, and that Visual field is classified as unreliable fixation if greater than 20%. If greater than 33%, then there is XX, which is definitely not suitable. So, upon continue, in the case of Humphrey visual field, there is a gaze tracking and monitoring at the bottom of the single print analysis. There is like, yes, let me show you. It's something like that. Okay. So, uh, here, the distance between corneal light reflex and the center of the pupil is measured. If corneal light reflex and the center of the pupil is this eye is rotating, you can see. Thus, the eye rotation can be judged. The error are indicating by upward deflection from the baseline. Means basically, no matter what you deflect a lot, then upward deflection is there. So upward deflection indicates the deviation due to the eye movement. Then what is downward deflection? Downward deflection indicates the patient's blinked when stimulus is present. So in this picture, this is upward deflection means the more from corneal light reflex to pupil center is deviated, more distance is there. Basically, eye is deviated. But this below means you blink whenever stimulus is presented. So that's a blink. Okay, it's very important to see that fixation gaze and understand what happens there. Okay. So now we are going to talk about false negative and false positive. So this chart is very important whenever you try to understand false positive and false negative, because in lot of every instrument you will see false positive and false negative. Every test you will see false positive and false negative. So let's take an example. Someone sent the spam message, and that spam message you have in your email, that technique, it will detect it's a spam message. Okay, so there may be a failure, isn't it? So there is a spam message sent and there is no spam message. This is message, second message is normal message, this is normal message. Okay, this is spam message, and the detection system says one times detected, one time not detected. And what happened if someone said spam message and system detected? That's good. That's where we want, isn't it? That's we call true positive. If someone said send spam message and your system says no, 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 that's normal. Okay, not detected. Basically means it's normal. It said it's normal, not detected. Then it's false negative. Okay, basically means it should be positive, it should be true because it's spam, isn't it? But it says negative. No, no problem. And then it's actually, that negative thing is actually false. So just remember, false negative means response is negative, but that response is not good, that response is false. So let's another which is normal message, no spam, but your system detected it's a positive, that it's spam, and your system detected, another system detected it's negative. We want negative, isn't it? Because true negative means no spam, and your system said yes, no, no spam. But that's normal message which is no spam. At the same time your system says no, it's positive, there is a spam. Then it's called false positive. Means this is very simple, it said positive response, which is false. Okay, and that's how it is going to be in our case. So false positive error and false negative error. See, false positive error is, this is the positive response to the patient even if stimulus is absent. So basically patient's response is positive, but actually there is no light, there is no stimulus. Okay, so it's called false positive chart catch trial. In this case, theta algorithm, the number of anticipated responses made too soon to light stimulus than expected level of false positive. So basically, whenever there is no light but patient is eager to just click that button, and there is false positive, chances of false positive goes high. Up to 20% is acceptable, but 33% you will see this. Okay, cross and cross. Basically, false positive means this patient response is positive, but actually there is no light, the response is false. Then patient should not press that button. So basically sometimes what do we call false positive, they have trigger happy patient, isn't it? They always want to just press no matter what. If there is no light stimulus, then patient is going to press. So that's trigger happy patient, so create false positive. False positive means there is no light but patient's response is positive, patients just click the button. Okay, so false negative, isn't it? There is no light, negative, but patient respond to it is false positive. But there is light, but patient response Negatively, patients say he cannot see, isn't it? That's negative. Patient's response is negative, but at the same time, that negative response is false. So, a fairly bright suprathreshold light target is flashed in the region previously tested with the Fender target. If the patient fails to indicate its presence, this records the false negative. Means the previously tested area where patient clicked, which is good. And again, you put the light, which is supra threshold than previous, and patient say no. Then in that case, it's false negative. Okay, it's called negative catch trial. The high false negative implies inattention or fatigue of the patient. So sometimes fatigue of the patient. That's why it's so crucial the duration of the test. Higher the duration of the test, chances are higher for negative false negative. Okay, acceptable is up to 20, but 33% above it means this cross and cross. So high false negative value indicate cross and cross. Besides the aberrant value and printed statement of low reliability in left corner, because you will see if there is a high false negative, then you will see cross and cross. Okay, it's very important to understand this concept. So you have to understand this concept. At the same time, you have to know this line. Always try to get false positive, false negative, and fixation loss 0 0 0, which is very ideal, isn't it? Respectively, in suspicious case like glaucoma. In established case, the advanced case of glaucoma, up to 20% of false positive, false negative, and fixation loss are considered to be acceptable, because they are advanced case of glaucoma. There is high chance the patient misjudges. There is high chance of false negative, false positive, and fixation loss. So just remember, you don't have to be always strict that it's the case, but that's not. Okay, so it's always remember that it's always important that established case and advanced case, there will be false positive and false negative no matter what. So that's why you have to stretch up to 20%, up to border of reliability. So that's very important. Okay, so that's again, we have finished this presentation. We are ready, which is a great book. Just grab that book, and this is also a good book for the reference of Humphrey Field. Okay, so next I think we will going to discuss raw data and grayscale and many more. So Bistan, cheers.